All right, we are going to be taking a look at approximately the first half of your reviews, reviews 1 through 4 in this video. Not going to be doing every single problem, just going to be doing some different types here, some places where we think you might be having some issues. So I'm going to start here at number 3. When we're dealing with inequalities and writing an interval notation, a couple things to keep in mind. One, we're going to have 2 inequalities that we're working with. My first job, if it's not done for me already, is to go ahead and get my absolute value expression isolated. If you try and separate them into 2 pieces first, you'll miss half of it. I'll just let you know in advance. So once I get to here and I go to split it into 2, the first one I just leave alone, and I've had some people ask me, well, doesn't that negative 2k become positive? The value that comes out of the absolute value is, but we're not doing a value, we're just doing an expression right now. So no, don't change that to positive. And then my second expression, leave what's in the absolute value alone, but the 2 things I'm going to change are I'm going to flip my inequality arrow, I'm going to change my sign. And then I'm going to go ahead and solve these. And remember, when you're doing these, negative divided by negative is positive, but when you divide by a negative to both sides, okay? Not just because you see a negative number, but I'm literally having to divide both sides by negative 2 in this case. You've got to remember to flip your arrow. And that's going to also be true in my second one. But don't stop. Write your answer in interval notation. Now again, if you need to make yourself a quick sketch of a graph, because you don't remember just looking at this if it's an and or statement, which we'll talk about in just a second, you can go ahead and make yourself a quick sketch. K is less than 1. Okay, it's going to be going this way. K is greater than 5. Greater than goes to the right. And then I just copy my interval notation to mimic that. Left to right. And then I start up again at 5, going to the right. Okay, so that'd be true on any of these. But again, going back to, can I do it without sketching? Sure. If you see your absolute value is greater than, that's an or statement. And again, the ors go out. If it's less than, that's an and statement. Typically your values come in or shade in the middle. Just a couple things to ponder. All right. Number 5. Identify the domain and range, sketch the graph. Now, personally, it's probably easier for you to sketch the graph first. Okay, so how can I do this? Well, I have several ways I can go about it. One of them is, of course, I could go to the calculator. Now, I'm going to try and make some connections here with what's going on with the calculator and also give some of you with these newer calculators a little bit of a warning on this. For those of us with the older ones, we just close the parenthesis. If you have one of these new ones, once you get done with what's underneath the square root, once I get that situated, then, and I might have just sounded a little strange there, I'm going to need to hit a right arrow to let my calculator know that I'm done underneath the radical. If I forget that, I'm going to get something different. But for our purposes here, okay, I go ahead, I'm going to look at the graph. Now, it doesn't mean something's wrong with my calculator. This literally starts here, and it doesn't keep going. It's just this right there. Well, how do I know where that point's at? Well, there's a couple ways. One, if you scroll up long enough, you're going to start getting error messages, which means your graph doesn't continue there anymore. That very first point that you see, okay, -4, -5 is your starting point. Now, besides that, I don't really need the calculator to do that, and here's why. Think about the shifts that are going on here. What's underneath the radical, what's in parentheses, anything like that every time is my left-right shift. So it means I went left 4. The second part's always my up-down value. Left 4, down 5. Oh, there's my starting point. Okay. And then to be perfectly honest after that, I just want to take some whole numbers that I have just to get myself an idea of where the graph's heading. Now, as far as my domain and range go, all the information I need comes from these shifts or this initial point. Because remember, my domain is my x values from left, starting at -4, to right. My range values are my y's going from the bottom, -5, to the top. So you see where finding that first point basically gives me my domain and range starting points. Okay? All right, let's keep rolling here. Solve by completing the square. Okay? It does not mean use by any means necessary. It means completing the square. So when I'm completing the square, I want all my x terms on a side by themselves, so this 23 is going to have to be moved to the other side. So when I add the 23, that makes that 21. And then again, the blank, remember our little tune from before. Take my b, cut it in half, and square it. That's what I'm going to add to each side. Once I've done that, and get back on the screen, I'm going to take that perfect square trinomial and get it into its binomial form, which basically is just taking my b divided by 2 number in here, and now I'm solving this equation. Take my square root. Here comes the detail portion of the problem. Squared means there's 2 answers. Whenever I have a quadratic, I've got to remember that plus minus is part of this. And if the radical broke down this time, I needed to, but this time it doesn't. And then I just minus my 6 over. Not underneath the radical. Okay? Not under radical, under radical. As good as I can do. Those are the type of things I've got to think about and go back with. And again, the sheets that I have randomly placed around the room and on my website with section numbers, if you look at one of these and are like, ooh, I need to see some more of that, go back, look at some of those things, and that's where you'll be able to find some more of that information. Okay? So when we get to the next part, okay, here comes factoring. And on each of these reviews, there's a lot of factoring in some places, on most of them, one way or another. So I'll do some random ones here and there. So if you don't see it on one review, you'll probably see it somewhere else. 13 I've noticed before, some of you panic when you see. Okay? I don't see anything in common. They all don't have an x. They all can't be divided by something. But what I do notice is I can deal with this problem, and we've talked about this before, as though it were 8x squared plus 18x plus 9. The only difference is going to be when I get to the parentheses, instead of x and x, it'll be x squared and x squared. So if you do mental math at this point, cool, do your mental math. If not, again, this is one of those places that you could, if you feel the need, you could slide and divide. Now, word of warning is always with slide and divide. A lot of you are good at getting to the part that we're about to get to right here. But then you're content and you think you're done. But again, it's not called slide. It's called slide and divide. So I've got to still go through and divide by my value. And if the fraction simplifies, I have to do that. So here, 12 over 8 simplifies. They're each divisible by 4. 6 and 8 both simplify. They're both divisible by 2. At that point, that's when you go ahead and you take that denominator and you swing it back to the front. And you also check to make sure that you can't factor any further. 3 isn't a perfect square. I can't go any further. Okay? Even if that was 9, I can't, because there's no such thing as sum of squares. So those are the type things I got to go back and look at in our other nemesis from the last quiz. Okay? Sum or difference of cubes. Nothing in common, but these are both perfect cubes. I've got to know my cubes. And I also have to know the pattern here. So again, my pattern. Keep the sign that you started with originally. And then we're going to work left to right. I square my first term, the 4 and the x, 16x squared. I change my sign. I take the product of my two terms, so 4x times 5 is 20x. And then I square my last term. Nice thing here, never going to have to do anything more than once. Nice, 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 nice. More factoring coming later, in later reviews. Those were just a couple on this first one I saw that I thought could cause some issues to get you to think a little. All right. Closest thing to a cheat sheet you're getting from me. Vertex form. There it is. So rewrite it using vertex form by completing the square. Okay. This one's the oddball. Different from circles, different from just doing it like we did earlier on this review. This one, my blanks, one goes on the y side. And I'm still going to separate off my x's, but I'm not moving the 13. So I'm still going to do my b divided by 2 and square it. And I'm still, just like I did before, going to turn that perfect square trinomial into its binomial form, either by factoring it or just by remembering it's the b divided by 2 number. And now I'm real close to it being this. All I got to do is minus the 9 over. And then it asks me to identify the vertex, which would be, which would be negative 3, 4. And that basically will take care of, or look at some of the questions from review number 1. All right, so we continue on here. Review 2. Graph each equation, identify the vertex, also identify domain and range. Okay, I'm going to start up at number 3 this time. Easy part is dealing with my vertex, which would be at negative 2, 1. Now, I can try putting this in the calculator using the absolute value function. I could make a chart, okay, that would be an option, just punching some values in. But remember, the easiest way to deal with these is to kind of use my slope value here in front. Different from a parabola, okay, we're not doing the 1, 3, 5 pattern, we're just kind of using this as my slope, which means if it's positive 2, I just go up 2 and over 1. And I do that both directions. And I'm going to get this symmetrical V shape. Don't make life difficult. My domain and range, then again, domain, that's going to be the easy part. Just goes forever to the left and right. And then my range is always going to go from the y value of my vertex to, in this case, infinity since it's going up, or negative infinity if it was going down. And that's it. Keep life simple. Positive opens up, negative's going to open downward. All right. So I scooch down a little further. Identify the transformations for the following functions, or for the functions. Sketch the graph, identify the domain and range. Okay, slightly different in that this time we're going to be dealing with this guy. And then you're like, oh, wait a minute. That's stuff from review 1. So I'm just going to put in a couple of reminders here instead of doing another one of these. My shifts underneath are my left, right. So this would be left 6 and down 3. But besides that, that's all I'm going to tell you on this one, because we just did one like this and I'm not going to go crazy. So with that in mind, after seeing it in review 1, we will flip to back. Move this down a bit. All right. Sketch the graph of the function. Okay, since we're in standard form here, to try and get that vertex, that center point to be working with, a couple of ways I can go at it again. One of the ways is to do my B to A. So the opposite of negative 4 would be positive 4. Over 2 times 1 would be 2. So I get my x value. And then I can either figure out my y by plugging that in. 2 squared is 4. 4 times 2 is 8, so minus 8 plus 8 would be 4. So my vertex would be at 2, 4. And since my a value is 1, again, now we're in parabola mode, so if we're going to go to a pattern here, it's up 1 and over 1, up 3 and over 1. And then again, if I wanted to keep going and I had the room, I'd be able to go to 5 and so on. So I get that graph, but it's not just equals, it's an inequality. So we chatted a little bit before, and we'll chat for a second again about another way I could get the parabola if I happen to forget, then I'm going to be over 2a part. So when I'm trying to do this, I am a fan of using a test point. So in this case, I'm going to use the test point 2, 6. And I'm going to plug those in for x and y. So let's see here. Always use parentheses when substituting where you're going to multiply by something. So let's see. 4 minus 8 plus 8 is 4. Is 6 less than 4? Not the last time I checked. So false means outside the parabola. True would be inside the parabola. Speaking of parabolas, what if I forget negative b over 2a? Am I screwed on that problem? No. What I can do is I can go ahead and I can pull up my chart. If I remember the x value, it's going to make it a little bit easier, because if I know what x is, I can pull this up to figure out what y is at. I can see the symmetry that's involved here, and then I can plot those points instead of trying to use the pattern. So there are options. The only part that can be bad with the calculator is if I happen to give you a problem with the next value that's a fraction, you're not going to see that in here. So I would just kind of work on making sure I know that. Okay. More interval notation, but this time I don't give you a graph. Well, what do I do then? I factor it. I could use the quadratic formula, but that's going to take longer. So I go ahead and I get this factored. Find out that my v values, or my zeros, would be negative 3 and 4. Again, this is just me. It depends on if you can just look and see by looking at the inequality what it's going to look like, or if you're a little more visual. Here, I'm going to test out a test point somewhere in the middle. So when I do my testing and plug in 0 for v, I get 0 minus 12. So is negative 12 less than 0? Last I checked, that's a true statement. So I'm going to be shading in that area, in the middle. If it would have been false, it would have been on the outsides. But remember, it says in interval notation, so we just go left to right. Now, you're like, I thought you said you could do this without graphing. Well, you can. Again, like we did up above, if I can look at this and go, ooh, this is less than, this is an and statement. And statements come into the middle. Or statements go out. So again, it's a shortcut, but you got to be able to remember it. All right, keep rolling here. Factor completely, 4 terms. Pair them off. Pull out LCDs. What do we have in common here? We have a 6 and the smallest exponent term we see, which is a squared. Already got the 6. To get from a squared to a cubed is a. 6 to get to negative 12 is negative 2. And if I did this right, second set of parentheses is going to give me the same thing. So I look, I'm like, dang, that's close. Negative a, positive 2. They're just opposite. How can I switch the signs on these? What could I pull out of there? Oh, yeah. I could pull out a negative 1. Because by doing that, that's going to change the signs on both of these, and now they're the same. But don't be done there. My answer is actually writing the greatest common factors as one of my factors. And the one they have in common is the other. Be careful. If this would have been like 9a squared minus 1, I could have factored again. Okay, but don't get sucked in here. 6 isn't a perfect square. I can't do anything more with that. Just leave that. All right. Solve by factoring. Solve is in what does the variable equal? Don't factor it, be done. Won't work. Okay. So here again, and I'm going to talk mental math this time. I could do slide and divide. But what I notice here is that the only way to get 7x squared is 7x and x. The only way I can get 10 is through 10 and 1 or 5 and 2. And I also notice that there's going to be 1 plus and 1 minus, and that my sum is going to be a positive. So I want the positive product to be bigger. Well, anything times 7 is going to be bigger. So I know that's going to work that way. And then I can just try numbers. And I'm like, well, if I put 10 here, that's going to be 70. That's too big. If I put 1 here, it's only 7. That's going to be big enough. 5 and 2. Ooh, 5. 5 would make this 35. 35 minus 2 is 33. Well, all right. But again, slide and divided work here too. But don't quit until you get the answers. Solve means give me the flippin' answer. And don't stop until you do. So again, just something to keep in mind. Okay. So now we're going to move on towards review number 3. So as we jump into review number 3, we start seeing some old school stuff like way back at the beginning of the year here. So again, I picked out one that caused issues before. You cannot get rid of the fraction first here. Okay, let me take that back. You could. But if you were going to get rid of the fraction first here, you would have to multiply every term, this one, and this one, by -7 right away. And so many people forget to do this part that I highly suggest you don't do it. So instead, I would suggest going this route. Because now when you go through to multiply both sides by -7, and again, don't distribute the -7 on the left side. Its whole reason for being here is just to get rid of that fraction part. And now, it looks like a normal equation finally. And I get myself set. Okay. The only other mention I'm going to make up here in the top before I start working down a little further is going to be on number 5. Reminder, before you cross multiply, please put parentheses on there so you distribute the 5 and the -3 to both terms, not just the x and the 2x, please. Thank you so much. All right. No time to go yet. Okay, number 8. Oh, one of our favorites, piecewise. Okay. Accurately graph these values. Now again, this is the one where we talked about you can do a couple of different things here. You can graph dots and erase. So for instance, if I was going along here on this one, I could go, okay, -x plus 6 if x is less than 0. So if I was going to lightly, and I'm going to do this lightly in pen and then go over it in a color, we'll see how this works out for me. Okay, -x, -1/1 means I'd go down 1 and left 1, down 1 and left 1, and I'd start making these points. But then I start to look at this for a minute, and it says, well, x is less than or equal to 0. So that means I want to be going left of 0. In other words, I want x values like 0, -1, -2, and so on, so on, so on. So I need to start doing the opposite of going down and right. I need to be going up and left. Because it means I'm going to start my graph at 0 with a filled in dot because it's or equal to, and I want to connect the dots that are to the left. I'm going to ignore those other ones that are there. I'm going to pretend you can't see them. And then I'm going to do the same thing on my other one. If I were graphing this one, my y-intercept, not x, is at -5. And I want the values that are greater than 0, or that are to the right of 0. Like 0, +1, +2, and so on. So let's see how this one works. So up 2 and right 3, up 2 and right 3. Okay, this one's heading the right direction. It's not or equal to, though. So I have an open circle at that 0. Okay, my graph has to start at 0, or whatever this number is for that problem. And this one's going out forever to the right. That's it. Now, could I punch these in the calculator and then just look for values and plot points? Sure, but you're not really going to have time to sit and play around forever. You're going to have to get down to business and know what you're doing on this final. So, just something to ponder. All right, flip over here. Oh, a couple more of our favorites. Gotta love them, gotta love them, gotta love them. So we get to the back. Oh, function notation. Maybe I'm going to do 2 here because this is a place where some of you started to get things a little mixed up before. We want to make sure we clean this up. F times g of x may also be written like this. Okay, means you're just multiplying those 2 quantities together. Now, when I say you are multiplying the quantities together, I'll say this again, it is going to stick. Do not just do first and last. Do not give me 6x cubed minus 10. Ugh. Foil it out. Use the box. I don't care which one you do, okay? But either way, you should be getting middle terms. If you don't, trouble will brew for you, okay? Foil or box out. If you don't, I'll be like banging my head into the desk because I'm grading these. Now, 11 and 12, though, not a dot. Open circle, G of F. They're compositions. May be written like this as well. They mean the same thing. Well, what does that mean to us? It means it's a 2-step process. I'm going to take my f of x function, okay, which is 3x squared minus 2, and I'm literally going to take this and plug it in for x in my g function. Do not multiply. Take that value, plug it in where you see x, and simplify it. So let's see, that'd be 6x squared. 2 times negative 2 is negative 4 plus 5 is 1. That's what I want. So if it's a variable, you end up with a polynomial expression. If it's a number, you end up with a numeric answer. There should be no x's in your answer if there's a number in the parentheses. Nope, 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 nope. Okay, factoring. I think this is factoring part 2. It might be factoring part 3. It's all a blur to me at this point. But before I start factoring, before you go and slide and divide, you know the question. Was that a long enough pause for dramatic effect? Okay. What do they all have in common? I noticed a couple of you that have screamed out 3 by now. Okay, so once we get that 3 out of there, it does not disappear. It just goes to the front of my expression. Do not stop. It's still a quadratic. It's probably factorable. Oh, yes, it is. Okay. Multiply to negative 16, add to negative 6. Now I'm happy. Don't forget the 3. Forget the 3. And then a few more cubes, which we've already looked at. So, don't go too much here. Okay, I am going to do 1 in 18. I'm not going to do all of them. But again, write an example of each. Okay, a quadratic function. What's quadratic mean? It means it's something squared. Y equals x squared plus 4. Whatever. Okay, just something that would give you a quadratic. And that's going to be the same for all of those. Okay. Our first look at exponents. So I get here and I go, okay, that 2 goes to every single term in here. Yes, even the negative 6. Okay. And when you're going power to power, what do you do to the exponents? You multiply them. So 4 times 2 is 8. 2 times 2 is 4. That's 6. That negative 6 is in parentheses, so don't mess this up. B squared and c to the negative 6th. Okay. couple things to be careful of. One, the only thing that flips is something with a negative exponent. Okay, so I'm actually going to take an extra step here to make sure I don't screw this up. This is in parentheses for a reason, so I don't get a negative out. So the only thing that's going to move is my c to the negative 6. That's going to go to the top and become c to the 6th. I still need to simplify. I see the same variable term in more than one place. So to get to my solution, okay, I'm dividing with the b's. What do you do to the exponents? You subtract them, and you put the answer where the bigger one is. 8 minus 2 is 6. Okay, c's, I'm multiplying what you do to the exponents. You add them, that's right. 4 plus 6 is 10. Now I'm done. Don't stop before then. Nope, 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 nope. Small movement here. Okay, more power functions. G of x divided by f of x. This can be the easiest and hardest problem all at the same time. No, you may not cancel the x's. Quantity, quantity. Unless they're identical, you don't do them. So as far as that goes, you're done. But restrictions. What could I run into with a problem on 25 if I don't put a restriction? I could end up with a denominator of 0, which is bad. So I got to make sure that doesn't happen. So I make sure that I don't get an x value that equals 0. And again, we don't write it that way. We're in a higher level math class. All reals not equal to 4/3. If you want to do interval notation, you can. If you want to write out all reals, you can. But you've got to signify that there's a restriction there. Okay, no just giving up and quitting on it. And then one more composition. Notice it's a number this time. So g of 2. Plug 2 into g. 2 plus 7 is 9. So this is really g of 9. She's like, wait, so I'm just going to plug 9 in there? Yeah. 9 plus 7, 16. You're done. It really is that straightforward. But you work from the inner function out, and then you'll be okay. Don't try to substitute g completely into g and then put the 2 in. That's going to make life too complicated. We don't like complication. At least I don't. All right. Last review in this first one. Oh, one of our favorites from back in the first 2 weeks of class. Okay. We're solving for m. M cannot be part of your answer. No, you cannot just subtract math and say a minus math equals m. Because then you have m in the solution and m that you're solving for. That doesn't work. So here's a different question. What do those two terms have in common? Oh, they both have m. Okay. So if I take an m out, I know this is going to look weird. What do I have left? M times what gets me to m? 1. Got to hold the place. Can't say nothing. M times what gets me math? Well, I've already got the m. So I need the f, and I got to be careful when I say that. You're like, okay, what good did that just do me? It got me from 2m terms down to 1, and now I can actually solve for it. Because I'm multiplying m by all this stuff, I just divide by all of this stuff. Which cancels all that out. Gets me a really weird looking answer. But it's the answer. Okay? So look for common terms. Look for ways to just keep chipping away until you can get to the value that you're looking for. And we keep scrolling down here. We've done some piecewise. Okay, factor completely. X to the 4th minus 81. Again, don't freak out by the x to the 4th. Remember, you see x to the 4th, pretend they're x squared. You're like, ooh, that'd be a difference of squares. Okay, let's treat it the same way. Except now instead of x plus 9, x minus 9, it's just squared. Okay, that's not a bad deal. Wait, what? I'm not done. What else can I do? Oh, yeah. I can break this guy down. He's a difference of squares. Can I break the first one down? No, there's no such thing as a sum of squares. There is cubes, but not squares. So, leave that guy alone. And again, what do I square to get 9? 3 with a plus and minus. Okay, don't be that person who almost gets there but not quite. So now, I dotted 9, but we've already done this. Why am I dotting it to do it again? That's kind of silly. So I'm not going to do number 9 right now. I'm going to move down to number 12. So 12. Now 11 and 12 share some similarities here. This goes back to on the last review when we put write an example of a quadratic, we put y equals x squared plus 4, okay? Here, what type of function? Is it linear? Is it quadratic? Is it cubic? What is it? Well, this one, again, this guy may have been a little while, is a step function. You remember when we did those ones and they looked like little steps and we kept doing this? Yeah, those step functions where the brackets were there, that's what that signifies. And that's all you're looking for there. We're not doing anything fancy. Nothing fancy at all. Keep life simple. Oh, the end is near for this first one. We're almost to the end of this video. All right, here come 2 more quiz nemesis. Would you say nemesis? I don't know. Nemesis. Do not here, you cannot square root right away. Okay, do not distribute the 3. Don't FOIL it out. We're trying to solve. Get the stuff out of there that doesn't let us get to x. Okay, now that you're here, again, do not FOIL. I mean, I guess you could and try to use the quadratic formula, but all right, 2 things to be cautious of. First, it's a quadratic. What does that mean? 2 answers, so plus minus. Second, does the 54 break down? Oh, but if it does, we've got to make sure we do it. If I can get a perfect square factor, better be sure that gets broken down. And then that 8 gets moved over. Now again, I'm not combining it with the 3. It's just going to sit there with it. Okay. So as we keep going, 15, 16, I believe we're going to hit in a later one. So I'm going to leave that be for right now. No, I'm not. Okay. First things first. When I'm trying to break this down, I know 81 has a square root of 9. Okay. What little number roots out here when I don't see one? 2, okay. So with that 2 out there, what else do I have to pull out since it's negative 81 I'm taking the square root of? You know it. What did somebody do with it? There it is. We're going to take an I out. I out. Okay. And then remember, it's just division at this point. It's just using my exponent rules. How many times does 2 go into 4? Twice. Do I have any left over? No. So I don't have any left in for the radical. 2 goes into 7 3 times. Do I have any left over? Yeah, I have one left over this time. So it's got to stay underneath the radical. So nothing too terribly awful there. And finally, 19. To get rid of the I in the denominator, I cannot just cancel the I's. I'd love it to be that easy, but it's not. We have to multiply by the complex conjugate, which means you change the sign of your I term. Okay, don't change them both, just the I term. And then you have to FOIL or box them both out. Again, you can't just do first and last or it doesn't work. So, for time's sake here, I'm going to go ahead and do out the multiplying here for us. And then we'll see how this breakdown is going to work. Okay, so if I boxed or FOILed this out, that's what I'm going to end up with. Now, it looks like a big jumbled mess, but this is going to clean up really nicely, really quickly. But before I can do that, one last question. What's I squared equal? Okay, -1. So up here, okay, 4 times -1, this is really -4. So -4 plus 6 is 2. 3i and 8i is 11i. Plus and minus 2 I cancel. That's good because we don't want any i's in the denominator. And then the opposite of negative 1 is positive 1. So positive 1 plus 4 is 5, and I'm set. Okay, this is going to conclude the first of our 2 review videos, 1 through 4. The rest are coming. If you need some more help in certain areas, again, you can do searches on my website, or again, I've got 3 signs up around the room with where sections are for individual numbers. If you need to go back and check some things on notes, keep working hard.